In this lesson, we are going to look at constructing perpendiculars to a line. And there's one main that we're going to do, and then one that you could learn, actually. It's a little bit of a one-off. But this main one we definitely need to learn because we have some conjectures associated with it. For our warm-up today, let's just remember, how do we construct a perpendicular bisector? This is really important. Draw a segment. Locate its endpoints. Make your compass over half the distance. Swoop, swoop. Go to the other endpoint. Swoop, swoop. Again, we did not change our compass distance. Connect these two. And in lesson 3.2, we noted a couple different things. That any point on the perpendicular bisector is equidistant from the endpoints. So that means, again, that this distance here will be congruent to this distance here, like if I measured this. And then we also noted that if a point is equidistant, so if we just know that it's equidistant, then we know it's on the perpendicular bisector. And to note that this is the perpendicular bisector, again, I mark this segment congruent to this segment and that as a right angle. For this one, now what we're going to do is we're going to construct a perpendicular from a point to a line. And so what that means is the point that we're going to work with is not on the line itself, and we want to get a perpendicular to it. So I'm going to draw a line, and again, I'm going to make it not horizontal, and then I'm going to pick a point somewhere up above it. It could be below, but I like to pick above it. And I'm just picking, I'm not trying to pick it so it's in the middle. I'm just literally picking a random point, and we're going to label it P. So that's stage one. Line, point. And now what I want you to notice is for stage 2, we have 2 points located on this line with swoopies. How do you think we got them? Well, we took our compass, and what we did was we made it so that if this is my point P, I want my compass to be open bigger than if I just kind of went straight down, but not too big, because if I opened it too big, then we're going to make a swoopy mark. I'm not going to actually hit the line, which is okay. I could just extend it, but just to save myself a little bit of work. And then what we're going to do is we're going to swoop to the right and to the left from P to that line. Now, what does that mean? Again, this distance, which again is the length from here to here, and this distance, the length from here to here, they are the same. And then what this guarantees us is that our point then will be on the perpendicular bisector. Now, I can't just automatically connect it. I don't know where it's going to be. Like I could think I'm connecting it perpendicularly and have it not. And so I still have to go through my perpendicular bisector technique, but now I'm using these A and B points, these points that I just created, to get them. The nice thing about this is, since I already have one point, I actually only have to make an arc strike either above or below. I don't have to make the double swoop. You certainly could. More is definitely not a big deal here. And then if we construct this, we are again guaranteed that this is on the perpendicular bisector of this AB, but what we're, because of the converse of the perpendicular bisector conjecture, but what we're really interested in is the fact that I have a perpendicular from P to this. So something that's interesting, and this is on the next page, so I'm going to bring that up, but then we're going to go back to that first page. We constructed our perpendicular bisector, and we're going to label our midpoint M. So I'm going to go ahead and do that. And we are going to pick a couple random points. And now it's asking for 3, Q, R, and S. I don't know. Let's just do 2. So we'll do the Q and the R. And then what we're going to do is measure the segments from P to those different created points, Q and R, and then we'll do M as well. And then we're going to ask ourselves which one of these has the shortest distance. So again, back to this construction that I just had. I'll pick a Q to go over here, closer to M, and maybe B, excuse me, R will be on between M and B, but it's not going to be the same sort of distance. So now what we're going to do is, again, measure. I'm going to take my ruler from P to M. So segment PM is about 24 millimeters, excuse me. From P to Q, I could draw a segment if I wanted and then actually measure that segment. Probably more accurate. This looks like it's 25. So PQ is 25 millimeters. Goodness. What do you think, guys? PR should be even longer. Looks longer. I would say that's about 28. And so which one was the shortest? This one right here. And what this means is when we talk about distance, anytime we talk about distance within geometry, we're always talking about the shortest distance. And quite often, the shortest distance is actually a perpendicular. I would say in most times, unless we just have 2 points that we're connecting and then we just connect them and then that is the shortest distance. But if we're trying to, for example, take a distance between 2 lines or a point in a line or something like that, the shortest distance is going to be along perpendiculars. That's what's going to give us what we would consider the distance. So the shortest distance from a point to a line is measured along the perpendicular bisector from the point to the line. Actually, I don't think it's bisector, guys. I think it's just perpendicular. For this next part of the lesson, what we're going to do is we're going to take a look at creating a perpendicular from a point on a line. So not to a line, but on a line. So this time I want you to draw a line and pick a point, any point. We'll call this X. I want to get a perpendicular here. How can I do that? Again, we know how to do our perpendicular bisector technique, but we don't have endpoints here, right? We know that something, if it is equidistant from the endpoints of a segment, it's on the perpendicular bisector. But then we also know that the perpendicular bisector hits the midpoint of a segment. So here's what we're going to do. You can pause the video and think about it more if you'd like. I'm going to extend this right just a scotch. I'm going to set my compass to kind of an arbitrary distance, and as long as it's not too long, or again, too small. If it's too long and too small, then it does create challenges with the constructions because then everything just has to be so smooshed together. I'm going to swoop on one side of the point that I put on my line. Without changing my compass distance, I'm going to swoop on the other side. What did I just do here? I literally created a segment. Let's say these are the endpoints of a segment. We'll call them A and B, where X is the midpoint. And again, how do I know X is the midpoint? Well, I made it the midpoint. I made it the midpoint because I made this distance, AX, the same as this distance, BX. And so now, to get a perpendicular at this spot, I use points A and B as my endpoints. I swoop, 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 swoop. Again, you actually only have to do one set of swoopies here because you already have a point on there. But I bet you if I connect these, they will go right through X. Gorgeous. In the video where we do some of the example questions, what you're going to have to do is also you're going to hit some vocabulary. So before you do these examples, I'm going to actually introduce some vocabulary. Great job.